In our next section here, we're going to look at the network address translation features of the ASA. We'll talk about some of the different types of network address translation, like regular one-to-one NAT, many-to-one NAT with the port address translation, identity NAT, NAT exemption, policy NAT. We'll see there's a lot of different terms that they use on the ASA for the network address translation, but in the end, we're essentially doing the same thing with all of them, just depending on whether we're using static configuration or if we're using an access list for our dynamic classification. We'll also take a look at some examples of this on the command line, and we'll again revisit this both on the iOS and when we get to our VPN tunnels to talk about how we need to do NAT exemptions when we are routing traffic over an IPsec tunnel or an SSL VPN tunnel versus the non-tunnel traffic. Now, overall, the ASA supports two basic types of network address translation. The first is the regular network address translation, or NAT, which is going to be for a one-to-one translation. Now, most of the time, this is the less common application of NAT because it would imply that for each of your inside hosts, you have one public address or inside global address that's going to be publicly routable for them. It's more typical in application to use the port address translation, or PAT feature, which is the one public address to many inside address translations, what's also known as the NAT overload scenario. Now, both NAT and PAT can be implemented two ways, with either static translations that are going to match on manual IP addresses or manual TCP and UDP ports, or dynamic translations where the addresses and the ports are going to be automatically allocated. Now, the typical cases that we would use static translations are when we have public services on the inside of the network. For example, our public web server or maybe our public mail server, that we want it to be visible from the outside, but not necessarily for every single port, or we're trying to share multiple public addresses, or maybe just one public address, with multiple inside private servers. So the two types of translations and the two ways that they can be implemented, this is the entire extent of how NAT can actually be used. Now, once we start putting these different combinations together, this is where the ASA uses these different terms to describe the particular type of translation that we're doing. Now, the first thing to note about the ASA is that the NAT process is not required by default. It used to be in the older PIX 6.3 code and before that network address translation was required even if you were translating the inside addresses to the same addresses on the outside. As of version 7.0, there's a new command implemented that is the NAT control, where NAT control is disabled by default. Now, if you were to enable NAT control, then it's going to behave the same as it did in PIX 6.3 and before, where for all traffic moving from the inside to the outside or back, you would have to do a translation. Now, whether you're translating to a new address or you're translating it to itself, which is sometimes called an identity NAT or a NAT exemption, when NAT control is enabled, you have to account for everything with the NAT process. Now, there's a major syntax change in the NAT process as of ASA 8.3, but the version that we are going to be focusing on in today's examples is going to be the releases that are before that. So as long as you're running 8.2 or below, then your syntax is going to match what the examples that I'm doing. Now, again, the reason why we would want to run NAT is if we're trying to hide internal addresses from the outside of the network. One of the particular reasons would typically be if we're not running routing protocols between the inside and the outside, where maybe on the outside we just have a default route that's going out to our service provider, which means that the service provider is not going to have a route back to our inside private hosts. So if we're using like RFC 1918 addressing, the 10 network, 172.16.31, 192.168, we're going to have to translate those as we move from the inside to outside to something that actually is publicly routable on the network. Now, most of the typical applications of NAT are going to be that normal inside to outside translation, which is when we're moving traffic from the higher security level to the lower security level. But we technically can have outside to inside translation, or any combination of maybe DMZ to outside, outside to DMZ. So we can get pretty complex as to the particular variation that we're configuring with the translation. But the key thing to note is that when we are doing an inside to outside translation, when traffic is returning on the outside, any type of access list that we're using for classification, it needs to use the post-network address translation addresses, not the pre-NAT addresses. So if we have a case where on ASA 2, we have the 10 network on the inside, and we have publicly routable addresses on the outside. We have this 200 network. If we are translating the 10 to the 200, when the traffic is returning back inbound, the ACL classifier is going to be looking at the inside global addresses, or essentially what we are translating to, as opposed to the inside local addresses, or what we are originally sourcing the traffic from. Another example for this would be if we have a public web server, and I want some address, let's say 200.0.122.100. I want this to forward TCP port 80 to the server. So when anyone on the outside, when they actually browse to that address, they're going to get redirected to the inside address 10.0.0.100. Now, when I do this, anytime I'm classifying traffic from the outside in, I would then need to reference the post-NAT address, the 200.0.122.100, not the inside local address, not the 10.0.0.100. Now, we'll be able to see from the debugs and the log messages on the ASA if we are using the wrong addresses for the classifier or for the access list. We'll be able to see if traffic is getting dropped. Is it getting dropped as it's going to the public address, which is the post-translation address, or is it getting dropped as it's going to the private address, which is the pre-translation? The vast majority of the verification we're going to do for NAT is going to be based simply on two commands, the show xlate and the clear xlate, where these are talking about our NAT translations. Now, there can be some potential issues you run into where if an old translation is stuck in the NAT table, the ASA does use this as a classifier for routing traffic differently as it moves from the inside out versus the outside in. And we'll look at some examples here of how that's different when we're doing a dynamic translation versus a static translation, where static translations are considered fully extendable, which means that we are allowed to move traffic from the outside in without first having to initiate it from the inside out. Now, the potential problem that you could run into is that if you're trying to do some sort of high availability design, and we'll talk about this more when we get to failover and redundant interfaces, but if there is old, stale information in the NAT table, you may need to clear those entries out with the clear xlate before your new translations are actually going to take effect. Now, we'll see that we can configure timeouts, whether they're absolute timeouts or idle timeouts, for the translation table. But if you do run into a problem with NAT, this is generally one of the first things that you want to do. Clear the translation table and see if the new translation is formed and it solves the particular problem that you're running into. Now, as I mentioned, the ASA uses some complex naming conventions for the different NAT processes. Essentially, what they're referring to is just these different types of either static or dynamic NAT or PAT translations. Now, specifically, the types would include dynamic NAT and dynamic PAT, where this means that your addresses are allocated automatically on a one-to-one basis or allocated on a one-to-many basis, where maybe you have just one outside public address that you're translating to multiple inside hosts. That would be a PAT translation. A static NAT or PAT translation, where with static NAT we're doing an exact one-to-one mapping, or with PAT we're doing a port forwarding mapping. The identity NAT, which is used to translate an address to itself, so it's the same on both the inside and the outside. A NAT exemption, which is similar to identity NAT, but is going to allow us to move traffic from the outside in, as opposed to just inside out and then return. Then we have both the dynamic and the static policy NAT. This is going to be used typically when we're doing NAT in conjunction with an IPsec tunnel that we want to control based on both the source and the destination of traffic, which types of flows are going to go to the NAT classifier and which ones are not. So I may be able to say from my source address, I want to use the NAT process if I'm going to some public address, but I don't want to use the NAT process if I'm going to an address that is over my VPN tunnel. So maybe from the 10 network to the 10 network, do not do translation. But from the 10 network to anything else, I do want to do the translation. So the first of these variations, again, the dynamic NAT and PAT, this is typically when we're translating the inside private addresses to a pool of public addresses. So maybe we have a cable modem on our edge and we have a few a few public addresses that the provider is allocating us. So as traffic leaves from the inside of the ASA to the outside, we need to translate it to whatever this particular pool that's being allocated to us. So our typical inside to outside translation. Now this on its own can be considered a firewall mechanism, specifically a stateful firewall mechanism, because with a NAT translation, when we are going inside to outside dynamically, it is not going to allow hosts on the outside network to initiate connections to the inside. And it's the similar logic as we saw with the modular policy framework inspection, where when traffic is going from inside out, we're creating the state. So we're tracking the individual flow, which is the source address, destination address, source port, and destination port. Then when the traffic returns inbound, and we are going from the low security level interface to the higher, we need to check the state table first to see if that traffic is allowed in. Now, the same case is true of the NAT process. When we move traffic from the inside NAT interface to the outside NAT interface, we create the state in the translation table, where we see that in the show xlate as opposed to the show connections. Now, when traffic returns from the outside NAT interface to the inside, this is only going to be allowed if there's already a translation in the table, in the xlate table. So even if I were to configure an access list that says allow all traffic in on the outside interface, nothing is going to be able to move from outside to inside unless there was already a translation to begin with. And this is the big difference between a dynamic translation and a static translation. In the case of either a static NAT or static PAT, it is a permanent translation inside the xlate table of our public to private address mappings, which means that hosts can move traffic from the outside to the inside without having it first to be initiated from the inside. Now, typically this is also used with the port number mappings, either TCP or UDP port numbers, where as I mentioned, we may have some public servers on the inside and we're trying to forward individual port values to them. But with that, it implies that we want to make sure outside hosts can actually initiate their connections in. So in the case of our particular topology, if we have that web server on the inside that has the address 10.0.0.100, I want to make sure that the flow can initiate from outside to DMZ, not just from the DMZ to the outside. So it's going to be two separate processes that we need to take into account. First, is the traffic allowed to move from the outside to the DMZ? This is going to be based on the security level, and it's going to be based on any access list exceptions that we are making to the modular policy framework. So once the traffic has been authorized to come in the interface, that the ASA says it's not going to be dropped by an ACL, then we would need to check the NAT table to see if the translation already exists. So if we were to have a dynamic translation from inside to out, even if we have the ACL in that is allowing the traffic, it's not going to allow the flow to move from outside to inside, or in this case, from outside to DMZ. So this is the big key point about the static translation. It's going to allow our outside hosts to initiate traffic to the inside. Now, the specific syntax for this in the ASA 8.2 and previous versions for dynamic NAT is going to be with the NAT command and the global command, where the NAT command is classifying what addresses do we want to translate from, and the global command is classifying what do we want to translate them to, where the global pool is typically going to be our public addresses, and the NAT pool is typically going to be our inside private hosts. So in this specific syntax, we're saying I have a NAT rule number 1 that says if traffic comes in on the inside interface and it's matched by the specific network and mask, I'm going to translate it to what is matched in the global pool as it leaves the outside. And actually what this should say, there should be a number 1 there as well. So this is how we're tying the inside pool, or the inside sources, to the outside pool that we're actually doing the translation to. So in the ASA, we can have multiple unrelated rules based on the number of the translation. So a NAT command with number 2 is then going to correspond to a global command with number 2, 3 to 3, etc. Now for the static translation, the syntax can be a little bit confusing here, because we say we want to do a static translation from the source to the destination, followed by the public address or the mapped address to the real address. And the logic that you want to remember for this is that it is high to low, low to high, where we are saying that as traffic comes in the high security interface, which is our inside in this case, as it moves to the low security interface, this is what we are changing it to. So this is the address that exists on the low security interface. If it came from this address, which originally would be on the high security interface. So when we're going from inside to outside, or DMZ to outside, it would be high to low, low to high. Where it would make more sense if this was the inside address and this was the inside address, but that's not how it works. It's mapping this address here, or this interface here, to what's matched on the real IP address. And the same would be true for the port numbers, where we're saying that this is where the traffic is originating, this is the address it's originating from, this is the address it's being translated to as it moves to that interface. So they're associated this way. So let's take a look at this in our particular design here, where the ASA is going to be translating traffic as it moves from the inside network out and also from the DMZ out. Now, what I want to do with these translations is I want two separate rules. I'm going to have a dynamic NAT rule that says when anything comes from the inside, so essentially the 10.0.125.0/24 or the 10.0.56.0/24, I'm going to translate all of these addresses into some pool that I'm specifying that's going to be on the outside. Let's say I'm going to translate this to 200.0.100.0/24. So I'm going to do a one-to-one dynamic translation. This address here, this address pool, would represent whatever the public address is that I'm allocated by the service provider, or if I have provider independent space, these would be the addresses that I am running with BGP. So whatever I'm actually allocated from IANA. Now, when we're doing this address mapping, one thing to keep in mind is that the routing process and the NAT process are unrelated. In order to do a translation, we need to make sure that the device, whether it's an iOS router or the ASA, is able to choose the correct outgoing interface for the traffic before it can actually be translated. Now, the potential issue where the common mistake is here is that if I'm translating these inside addresses to this outside pool, when I actually send my traffic out, how are the destinations going to know how to get back to me? If they do not actually have a route to the pool, to 200.0.100.0/24, then they're never going to know where did the traffic actually originate from. So whatever addresses that we are translating to, we need to make sure that everyone has a route back to that pool. Now, if it's our connected interface, it's probably a little bit easier to solve because in this case, in our topology, we already know that everyone has a route to this VLAN 122 because we're running IGP on the interface. But in the case where we're translating to some arbitrary addresses, like here we'll say 200.0.100.0/24, unless I actually advertise this, the translation will work, but then routing will fail. So we'll look at both cases. We'll look at with the translation working and the routing failing, how we can see that that's exactly the problem, and then how do we solve it by having the correct translation and the correct routing at the same time. Then once we do our dynamic translation, we're going to look at doing a static outside to DMZ translation so that we can get access to the ACS server. I'll say that this address 10.0.0.100, I want to map it to an address on my outside interface. I'll map it to 200.0.122.100. So when people send, let's say, network time at UDP 123, that it's actually forwarded inside to the ACS server. Or when they're sending TACX, where the TACX is going to use TCP 49, I want to make sure that that request can actually be forwarded to the inside host. So we'll do a static translation. We could do this again on a one-to-one basis, or we could do it on a per port basis. So let's take a look at the command line now. And again, the first thing we're going to do is the static translation, the one-to-one translation from the inside network to the outside network. So on ASA2, if we look at the show IP, on the inside network, we have the 10.0.125. On the outside, we have 200.0.122.12. So outside is going to be our public link. Inside is our private link. So I need two attributes to be defined here. What are the addresses that I'm actually going to translate to? This is what's defined by the global pool. These global addresses are going to exist on the outside. That's where they're routing towards. Then we have the NAT identifier. This is any locally significant number that is going to bind the global statement to the NAT statement. So when I create my NAT statement, I need to make sure that it says 1. Okay, enter a range of addresses that I want to translate to. I want to translate to 200.0.100.0 to 200.0.100.255. So this is my NAT pool that I'm translating to. Now for the actual translation of the sources, it says what is the particular source IP addresses that we want to match. Now there's a couple different ways that we could do this. We could match the specific addresses based on the subnets. Like I could say 10.0.125.0 with a mask of /24 and do another statement that says the 56 address, so that's between router 5 and router 6. When we look at the show run NAT, we can see that they're two separate statements. Now I could also just say for any packets that come in on the inside, those are automatically going to be translated. So when you use zeros with the NAT statement, it means you don't care what the source address is. So I'm essentially saying all traffic that comes in on the inside interface is going to be translated to the global pool that starts at 200.0.100.0, goes through 200.0, 100.255. Now let's actually try this out. Let's look at the show xlate on the ASA. We could see up to this point we've had no translations because we don't have any actual traffic moving between the interfaces. If I were now to go to router 5, and let's say that I ping 200.0.0.2. This is router 2's address. Now, if we look at the ASA and look at the show xlate, we can see that we have a translation where it says the global address was 200.0.100.93, and the local address is 10.0.125.5. So it randomly picked some address that was inside the global pool that I was using. If we look at the show connections, it says there's a connection that should be allowed back in from router 2, which is going to this address on the inside. So essentially the translation table and the connection table are going to work hand in hand to figure out, is the traffic actually allowed through? And if it is allowed, what's the addresses that they're supposed to translate to? Now, if we were to go to router 2 and look at the debug IP ICMP, router 2 says that I am sending ICMP echo packets from my own address. My address is 200.0.0.2. They're going to 200.0.100.93. So this is the post-NAT address. This is telling us that the translation did occur successfully on the ASA. Now, if we actually looked at the debugs on the ASA, we would see the translation occurring for whatever host that we have on the inside. The same would be true if I went to router 6 and I did a ping of another address or router 2. This second host, it's being translated to 200.0.100.110. So it's a little bit different than the iOS, where iOS is going to go sequentially with the numbers, where the ASA is using some sort of internal binary logic to figure out what's the result that we're translating to. Now, I don't really care what it's being translated to anyways, because this flow is only going to be allowed inside out, never originated from the outside to go back in. Okay, so we can see now the translation is working. But if we look at router 5 and router 6, the pings are not actually getting through. The reason why is if we go to router 2, let's look at the debug IP packet. Router 2 says that this particular destination that I'm trying to reach, 200.0.100.93, it's unroutable. So the issue now is not in the NAT process of the ASA, it's that I did not account for the routing of traffic back to the global pool. So the key point of this design is that anytime you are translating to a pool that is not already directly connected, where in this case I'm not translating to the 122 address, I'm translating to some other random pool, 200.0.100.0/24. I now need to make sure that everyone else on the outside has a route back to this. Another typical problem case when you're doing this is anytime you're doing the EasyVPN client or the SSL VPN client. If we're doing a network address translation for the client's traffic to go to the public network over the VPN tunnel, we need to make sure that whatever address pool we are allocating for them, that the devices in the network have a route back to that. Now, when we get to IPsec and SSL VPNs, we'll look at exactly how we do that, the different types of split tunneling configuration, the automatic advertisement of the addresses, whether we're using the VTI, the virtual tunnel interface on the iOS, versus the manual configuration of routing on the iOS or the ASA. There's a number of different ways that we can solve the problem. But the first step is to realize that it is an issue to begin with, that the NAT translation and routing, they're completely unrelated. You have to solve routing first, otherwise the translation is going to be meaningless. So now in order to do this, what I essentially need to do is just tell router 2 that 200.0.100.0/24 network is reachable via the ASA. Then I can advertise that to whoever else is in the topology. So I'll say simply to get to 200.0.100.0/25 or /24, I'm going to the outside interface of the ASA, which is 200.0.122.12. Now, under my routing process, which in this case is OSPF1, I'm simply going to do a redistribute static subnets. If we now look at router 5 and router 6, we should see that now the traffic is working bidirectionally because the NAT translation was fine, and now we've also solved the routing process. If we vary the input for where the source addresses are coming from, so let's say on router 6, I telnet to router 2 and look at the show users. This is going to show me what is the source address that I came from. So I came from that .110 address. If I were now to change where I source the traffic from, so let's say the source interface now is my VLAN 6. So it's a different IP address than before. If I look at the show users, notice that this is a new, essentially random address from our point of view. That based on the input of the inside source address, we're going to end up with some address that's inside the global pool, but we don't necessarily know which one. And the reason why we don't know is because the process is dynamic. If we wanted to allocate a specific address, we would have to do the translation statically. Now, we can have overlapping static and dynamic translations where the static one is going to take precedence. So let's say now, for example, that when I source traffic from router 5, okay, you can see these drop pings. That's because we're policing the ICMP on the ASA. On router 5, let's look at the show IP interface brief. I have two interfaces that are running IP. My interface that is facing towards the ASA, when I send traffic out, this was being translated to the .93 address. So that asterisk there, that means that this is my open session. This is my active session. Okay, now let's say that when I source traffic from router 5, and it comes from this address, the 56.5, I want to translate it to 200.0.100.5. So the address is still part of the global pool, but I'm essentially manually pulling one of those addresses out. And we can have overlapping configurations like this. So on the ASA, we'll say we're going to do a static translation. Traffic is coming from the inside, and it's going to the outside. Inside, comma, outside. We're going to translate the address to 200.0.100.5, but only if it came from 10.0.56.5. if we look at now the show xlate or the show xlate detail, notice here the flags in the translation table. This first entry is static. Now, the reason that this is significant is not only that this is going to be a permanent translation. So on router 5, if we were to telnet to router 2, but I'm going to source my traffic from fast Ethernet 0/0, so it's coming from that 56.5 address. When we look at the show users, we can see that now the traffic is being translated to that .5 address, because that's what I'm doing the manual static mapping to. So it's always the same address when I'm going from the inside to outside. But more importantly than this, what it's allowing me now to do is to move traffic that is originating on the outside to inside, because this is a permanent translation in the table. Now, the other ones, it says that these are identity translation, or excuse me, these are dynamic translations, the lowercase I. So it means that we cannot go outside to in for these. Now, on the ASA, if we look at the show access list, my access list outside in is already permitting all telnet traffic. So if I were to go somewhere on the outside, let's say I go to router 4, and from router 4, I'm going to telnet to 200.100.5. Notice that this is sending me to router 5. Now, from router 5, if I were to telnet back to router 4, which in this case is 172.16.34.4, this traffic is being translated to the .93 address, so it's not a static translation, because it was being sourced not from that address that I'm matching. Okay, the address I was statically matching was the 56.5. So when router 4 is getting this, it is seeing the .93. The difference being, not only is this one a dynamic translation, so we can't guarantee what the address is, but if I were to telnet back to this address, and actually I need to delete the translation. Let's say on the ASA, we'll say clear xlate. That's going to delete the translations from the table. On router 4, if I now telnet back to this address, it's not going to be available, because it's only a temporary translation that it requires the inside host to first initiate the traffic before the translation occurs in the table. So now in the ASA, when we look at the show xlate, that dynamic translation is not there. The static translation is, though, which means I should always be able to reach router 5 by using the .5 address. And this is mainly the difference between the dynamic and the static translations. Now, it is, of course, again, that you're always going to have the same address when you're doing it statically, but more importantly is that you will be able to initiate traffic from the outside in. For a dynamic translation, it is inside out and then the return, but never the outside actually originating the traffic to begin with. So this is the reason when we are trying to do port forwarding or to do a one-to-one address mapping for our public servers, we need to do this with the static statement and not with the NAT statement. Otherwise, we would be first waiting for the server to initiate the packets out before the traffic would be able to use that translation on the way back in. So now let's say that we want to do this for the ASA. And I want to do the translation, so when I hit 200.0.122.100, but only at port 80, I want this to forward into the ACS server. And the ACS server, it should already be running its Windows web server, the IIS server. But let's double check this. So from the server itself, let's go to 10.0.0.100. Now we can see it doesn't actually have a page configured, but the service is at least running. So let's see, if I were to go to the inside network, let's say I were to go to router 5, and let's try to telnet to 10.0.0.100 at port 80. This means that the service is closed, so I need to turn this on. And if you are using our rack rentals for any of the security stuff, you'll see the Windows service does have a lot of these services already installed that you can use to play around with these testings. Specifically, in this case, I need to go to the Internet Services Manager and then make sure the website is on. So let me stop and restart the service. Then I may need to actually create a page. It says let's see, what is the root of the website? Directory is inetpub/www root. So let's do this. Let's just make a new file here. We'll say index.html. And just some basic code on this page. So HTML page. And let's see, now if I browse to $10.0.0.100/index.html. Okay, so now the web service is listening at least. I should now be able to go to router 5 and open that session, unless this is actually being denied by the ASA. Okay, now if you run into this type of problem that you're having a connectivity problem, but you don't know exactly where the issue is with the transport. So right now, I don't know, is it a problem with ACLs? Is it a problem with the modular policy framework? This is where the logging on the ASA is going to come in handy. So let's turn logging on at level 7. Logging on in logging console 7. Now, I should be able to move from the inside to the DMZ because I'm going from high to low. So these pings are getting dropped. Let's see, what does the ASA say? It says that the port map translation created failed for ICMP source inside for the destination DMZ. Now, what this means is that now there's an issue with the NAT translation. So if we look at let's look at the show. Port map translation creation failed for ICMP source. Let's see, from the ASA, can we ping? The ASA should be able to ping that address. What I may need to do now, since I have the NAT process configured on the inside interface, I may need to do an exemption as it's going to the DMZ. Because what this is saying is that the this is basically a NAT debug that we're trying to create an xlate for it. When we look at the show run NAT and the show run global, the NAT rule is saying that I don't care what traffic it's coming from. As long as it's coming in that interface, it should be going through the NAT process. Now, which is fine when it's going to the outside interface because I know what the translation is. But the problem is I have essentially like a null translation to DMZ. So I need to tell, no logging on. I need to tell the ASA that from inside to DMZ, I do not want to do a translation. So even though NAT control is off, let's say show run all NAT control. So no NAT control is enabled. So NAT control is disabled. Since I am matching the NAT statement on the inside, it's assuming that I need to do a translation as I'm going to DMZ. So what I'm going to say now is NAT on the inside for 0. That, let's see. Let's actually come back to this in a little bit because I'm trying to do the translation from the outside to the DMZ anyways, not from the inside of the DMZ. So let's see on router 2. Let's look at the ASA's access list. Let's say show run access list. And just temporarily, I'm going to say access list outside in permit ICMP any. Okay, so I'm allowing all traffic to come in on the outside link. Now from router 2, this should then mean I should be able to ping the DMZ. This means it's being intercepted by the NAT process then. Let's say this. Let's say logging console 7 and logging on. No translation group found for the outside to the inside. So I need to do an exemption between the two of these. Let's go ahead and take a short break here. And I need to double check the rest of the config that I actually have on the ASA. But essentially, once you turn the NAT process on, as you can see, it does behave like NAT control is on, but only for the links that you have configured it for.